Finding unknowns.
Finding unknowns. Okay, that is a pretty good one. Now remember when we started the class, and what we're actually gonna do today is we're gonna go back to day one, and we're gonna look at all of the things that we did from day one, and we're gonna see how algebra applies to these things. Now, the first thing that we did was, what is mathematics? Mathematics is the language of numbers. So we have two things. We have numbers, which are things, and we have operations, which is what we do with those things. This is what we were talking about from the very first class, and we saw that these are operations right here. So the thing is that this is all that we have to deal with in the whole of maths, right? The thing is that sometimes these numbers can be unknown, right? So we end up having to use, like, letters to represent unknown numbers, right? So what we could say is algebra. It is the language and I hope you guys writing all this stuff of mathematics itself. It is the language of mathematics using unknowns, variables. An unknown is also a variable because it could be anything, it could vary. And generalization. Now, at the end of the day, we spoke a little bit about generalizations. We saw a couple of them in the last couple of weeks, and we're going to see some more of them now. So, we're talking about the things that we were doing since the very first class. And in the very first class, the first thing we were looking at was this simple addition. And we were saying 4 plus 3 equals 7. And then we were saying here, well then we actually proved it by counting 4 cherries and adding it to 3 cherries to get 7 cherries. And then we changed the order. 3 plus 4 also equals 7. So we saw here that addition is, where's the word for it? When you could, yes, commutative. Now, a lot of people do take this on. Addition is commutative, blah, blah, blah. Who cares? But it's a big deal because this is the thing that you always forget when all you're doing algebra. Yeah? So let's see how algebra applies to this. If I had, and I hope you guys writing while I write in, right? Because I just go fast. If I had, oops, not 4. If I had 3 plus 4 equals 7, can I say that 3, therefore, 3 is equal to 7 minus 4? Is this true?
Yes.
Yes. And how is this true though? How? How? Right, yeah, absolutely. We know that. But how do I get from here to here?
Yeah, bring the 4 over 3 equals 9 by 7.
Caitlin, you understand what she's saying?
Yeah.
And at the end of the day, this equal sign is the biggest thing. That equal sign means that that is an equation. An equation has an equal sign. So an equation, you could think of an equation like a scale. and the scale needs to be balanced on both sides. So on this side I have 3 and then I have 4, and when I add the 3 and the 4 on this side I'll have 7 just to keep it balanced. Now we could see here that I have 3 plus 4 equals 7. What I need to do to get rid of this 4 is I need to take it out the scale. But if I take the 4 out the scale on this side, I need to do the same thing on this side in order to keep it balanced. So what I need to do is minus 4 from both sides. So what I'll end up with here is 3 plus 4 minus 4 is equal to 7 minus 4. The 4's cancel. Now I'll have 3 is equal to 7 minus 4. Caitlin, you alright with this so far?
Yeah.
You okay, right? So my question is, what if this 3 was unknown? What if we did not know what number that 3 was? So we'll just call it x. So we'll now have x plus 4. We don't have to call it x. We could call it anything we want. P, Q, N, M, R, A, Z. Does not matter. It just means that it is unknown. Right? So if I have x plus 4 equals 7, how do I find what x is? What do I do?
Carry across the 4.
Carry across the 4, and I'm glad that you all saying carry across the 4, because what do we call that? We call that transposition. So to transpose is not carry across the 4, it's transpose the 4. But what am I doing when I transpose the 4? What am I actually doing? Huh? Grouping like terms is correct, but what I am actually doing to the scale, when I throw across this 4, what am I actually doing to the scale? Remember, an equation is a scale, and it's a balanced scale. So what I am actually doing is I'm minusing 4 from this side, and transposing the 4 means that I'm minusing 4 from both sides of the equation, right? So now I'll have x plus 4 minus 4 is equal to 7 minus 4, and these 4's will cancel, so I'll have x is equal to 7 minus 4. So look, we have transposed the 4. We threw across the 4, and now it became minus 4. But this is why. What we actually doing is we actually removing or minusing the 4 from one side of the scale, which means we have to minus the 4 from the other side. You okay with that, Caitlin?
Yes.
Alright. Easy stuff so far, right? Right. Now, we took a look at this, and we saw that 4 minus 3 is 1, but 3 minus 4 does not give us 1, it gives us minus 1. So that means that what? Subtraction is not what? So these things, you notice this commutative thing, I keep bringing it up. It starts to become really important when you're dealing with unknown numbers, right? So similarly, I could be dealing with x minus 3 is equal to 1. How am I going to find what x is?
Can you transpose the 3?
So I transpose the 3, meaning what? What exactly am I doing to transpose the 3?
You're minus the 2 from both sides?
Probably from both sides, but the thing is, I already have a minus 3, eh?
Yeah.
So if I minus 3 from both sides, x minus 3 minus 3 will give me x minus 6. Eh?
Mm-hmm.
So minusing 3 is not the answer here. What do I have to do to both sides of the equation? Caitlin,
Add 3.
you have to add 3. Does that make sense, Kosha?
Yeah.
So if I add 3 on both sides, now I'll have x minus 3 plus 3, which is equal to 1 plus 3. So I'm adding 3 to both sides. And now these two will cancel. Negative 3 plus 3 is 0. So x is equal to 1 plus 3. X is equal to 4. Now you could see here, what you guys were saying is transpose the 3. You take the negative 3 and you fling it across and it will become positive 3. But the question is, why does this work? This is why this works. You understand, Scotia?
Yeah.
So this is why transposition does work. When you are transposing, you know, generally when we transposing, we could go from this step to this step and basically skip this step. But this step here is the reason why it works. Right? That is the reason. So nice. So let me talk a little talk here now. Just now. Let me just see something. All right. What if I was to have x plus 2? What will I get when I add x plus 2? That equals what?
To x.
Scotia?
We don't know what x is, so...
Right, exactly. We do not know what x is. We do not know what x is. So x plus 2 will just remain x plus 2. Right? Remember when we were talking about addition and we were saying that this is a unit, this is a unit, and the addition sign just kind of separate the units. Remember when we were saying that? However, addition is commutative, so this could also be written as 2 plus x. Okay. So you're okay with that, Caitlin?
Yeah.
Right. So what about if I had x minus 2? What could that be written as?
2 minus x.
Ooh, 2 minus x. You agree with this, Caitlin?
Yeah.
You agree with that? So alright, so let me see. 2 minus x. X minus 2 is equal to 2 minus x, right? So if x was 1, let me just say x was 1. What you're trying to say is 1 minus 2 is the same as 2 minus 1. Is that what you're saying?
No.
Because 1 minus 2 is negative 1 and 2 minus 1 is positive 1. So this is not correct. Why? You just do it right here. Where is it? Where is it? You had it right here just now. Look this here. Subtraction is not commutative. Remember that, Scotia?
Yeah.
So x minus 2 is just simply x minus 2. I can write it the other way, you know. I can write it the other way. But each number must maintain its quality. So if this 2 is negative, I could put the negative 2 over here, and this x is positive, so I could put the positive x over here. So yes, I could rewrite it like that, because I am treating it here like an addition rather than a subtraction. But I cannot say 2 minus x, because look, the numbers have changed their quality. 2 is now positive, x is now negative. So in this case, x is a negative number, but here x is a positive number. So they obviously cannot be the same. They cannot be the same. So Scotia and Caitlin, do you understand how I got from here to here?
Yeah.
Yeah.
Alright. Now, what if I have x plus x? Yes. No. This is 2x. Why though?
Both x.
Yes. We don't know what the number is. X is an unknown. But look, I use x again here. So these two are the same number. So once I use x numerous times in the same equation, they will always mean the same number. Yeah, whatever x is on this side, it must be the same thing over here. So let's just remember basic arithmetic. If I have the same number added to itself, that just means 2 multiplied by the number. Yeah? 4 plus 4 is the same as 2 multiplied. I have 2 4s. Yeah, look, I have 2 4s. Huh? So in this case, I have 2 x's. You okay with that? Caitlin?
Yeah.
So you could see here that x plus 2, you had said this was 2x, but no, we can't do that. X is unknown. But because we're dealing with 2 of the same unknowns, they're the same. So we could say that we have 2 of them. Right? Now, a way to make a note of this. Addition, this kind of separate the units. So these units are being separated by addition. Right? But with multiplication, we could see this as being one unit, one single entity. And we spoke a lot about that when we were doing algebra, right? So if this is the case, what if I was to have 2x plus 3x?
Why?
Caitlin, will you agree?
Yeah.
Yeah, if I have 2 apples and then Scotia give me 3 apples, I'll have 5 apples, eh? Yeah, so I have 5x. What if I have 2x minus 3x? What am I gonna have? negative x or negative 1x. You okay there? Caitlin, you alright?
Yeah.
Yeah. Alright. So what if I have x plus y? What will I get here?
Can't do anything with it.
I cannot do anything like with that. But I could say x plus y is the same as y plus x. Would you agree with that?
Yeah.
And why? Why is this the same? Because
Everything is commutative.
so now we have used algebra to come up with a generalization for this rule that addition is commutative. Okay? But what if I had this? X minus y. What will I end up with?
Still x minus y.
X minus y. Right? Is there any other way that I could write this?
Yeah.
How?
Minus y plus x.
Minus y plus x. You understand why, Caitlin?
Yeah.
Alright. So cool. What if I had negative 2x minus 3x? What is that?
Negative 5x.
Right. Why? What's the rule for this? When you have the same signs, what do you do?
Yeah, add.
And you keep the sign, eh?
Yeah.
Right, okay, nice. And when you have different signs, as we saw here, you subtract and you keep the sign of the larger number, eh? Yeah?
Yeah.
Right. So, these are the rules. And the point is, these rules here, right? That you have the same signs, you add and you keep the sign. If you have different signs, then find the difference and keep the sign of the larger number. You remember these rules, Caitlin?
So,
So the whole point is all of these things that we learned in the past 6 classes coming right back now for algebra, because algebra is nothing special. It's the same numbers that you've been using all the time. So my question is, can you come up with a generalization for these rules using algebra? Remember how we had come up with generalizations for fractions and things? So can you come up with a generalization for this one? If you have the same signs, you add and you keep the sign. Any ideas? Caitlin?
Thinking, hold on.
What about this? Negative x minus y. And they have the same signs. So what you do is you add them and then you keep the sign. What do you think about that, Caitlin?
Okay, yeah.
Yeah, so it's not that tough. What about this one? Now this one is actually harder because different signs, when you have different signs, you find the difference, but you keep the sign of the larger number. So when you have different signs, you find the difference. That is easy enough. But this one, keep the sign of the larger number. We had to add an extra statement for that. So any ideas? For different signs, so let's just say I have x minus y. So these two guys have two different signs. This is a positive x and this is a negative y. What you do, you find the difference, x minus y, and you keep the sign of the larger number. So you keep the sign, but then you have to state if y is greater than x. How will you feel about that generalization? Are busting on your brain yet?
No.
Caitlin, you alright?
Yeah.
You sure?
Yeah.
Alright. Now let's talk about multiplication. We were talking about addition and subtraction there. Right? And actually, let's just do a couple more addition and subtraction questions before we start to talk about multiplication, right? Let me see what you could do with this. 3x plus 2y minus 5x minus 3y plus 2. What is this going to equal to?
The x's and the y's together. So
I'll group the x's and the y's. So I'm dealing with the x's together and I'm dealing with the y's together. So 3x minus 5x and then plus 2y minus 3y and then I have the plus 2. So what this is gonna give me? Caitlin.
okay.
Minus what?
Minus y and
Oh, yeah. Plus 2.
plus 2. Good job, Caitlin. Very good. Now let's talk about multiplication just a little bit, right? So what will happen if I have 2? You could see here that when I had before, when I had x plus x, that gives me 2x, because multiplication is just repeated addition. And whilst these are separate units, if I write it as a multiplication, I could treat it like one unit. Multiplication and division. Right? So we could see here that 2 multiplied by x equals 2x. What am I gonna get if I have negative 2 multiplied by x?
Negative 2x.
Negative 2x. What is the rule here? And look, you have the thing here. Once you have the same signs, your answer is going to be positive. So if you have two negatives, negative and a negative gives you a positive. Positive and a positive give you a positive. Once you have the same signs, the answer is positive. Once you have different signs, the answer is going to be negative. That is the rule that we're dealing with, right? So in this case here, I have different signs, so my answer is negative. So what am I going to get, Caitlin, if I had negative 2 multiplied by negative x?
2x.
2x, very good. So Caitlin, try this one. What am I going to get if I have x multiplied by x? Nope. This is it would have be 2x if it was x plus x, eh?
Yeah.
X plus x is 2x. But what do I get when I have the same number multiplied by itself?
I'll be x squared.
What do you think, Caitlin? And if I have 4 multiplied by 4, I could say that that is 4 squared. You understand, Caitlin?
Yeah.
Right. So if I have x multiplied by x, I could also write it as x multiplied by x, which is x squared. What if I had x multiplied by y?
xy.
X, y. Now, this doesn't mean anything different from this. Just like how 2x actually means x multiplied by 2. That is what 2x means, x multiplied by 2, x 2 times. But because it's a multiplication, means that I could treat it like a single unit. So it's the same thing over here. X times y is a multiplication, so I could treat it like a single unit. Is there any other way I could write it though?
Something?
Well, what is it?
I don't know.
Any other way I could write it, Caitlin? What about yx? Could I write it like that?
Yeah.
Caitlin, do you think I could write it like that?
Yeah.
Y.
It's commutative.
Yes, this is the general rule that multiplication is commutative. So you see here that we have a generalization for the multiplication being commutative, right? So we have multiplication being commutative here. What if I had a half multiplied by x? A half x, yes. Is there any other way to write it?
I mean, I would say x half. That will look good in my head.
Yeah, no, x half is correct, but it really does not look good. And usually we will put the number first before the unknown in a multiplication, right? And this number is called the coefficient. So this is the coefficient of the unknown, the number that comes with the unknown. But look at this same thing. So you see here, we was talking about this last week in normal computations, and now we meet it in algebra, and all you know what to do. Yeah, this is exactly what I was talking about, and look, we was talking about it right here. 4 multiplied by a half is the same as saying 4 over 1 multiplied by 1 over 2. You multiply your numerators and your denominators, you'll get 4 over 2, which is 2. Remember you were saying that?
Yeah.
What we were saying is that this is actually a division, and that division is really just multiplication by a fraction. Remember, we were saying that? So you see how all of these things, once all you see x in front of all you know, all you just can't think. So, where's another way to write this now?
Multiplied by x over 1.
Well, yeah, sure. Well, this is a half multiplied by x over 1. Caitlin, I do not appreciate your silence, eh? Even if you don't know it, right? So, this will mean I'm multiplying my numerators and my denominators. So, x times 1 is x, 2 times 1 is 2. And?
Yeah.
So that gives us x on 2. And this is one of those things that give you guys a lot of problem. Understanding this, when all you bounce up this in algebra, all you just forget it. What about this one? 3 on 5 multiply by x. What am I gonna get there?
3x over 5.
3x over 5. Caitlin, do you agree?
Yeah.
Alright, x is over 1. Multiply your denominators and your numerators. What if I had 3 over 5 multiply by 1 over x? What am I going to get here?
3 over 5, right?
3 over 5x. Caitlin, how you feel about that?
Good.
You sure?
Yeah.
Because you are remarkably quiet. I know you're quiet by nature. Eh? But this class is not nature. What if I had 2x on 3 multiplied by 9x on 4? Caitlin, let me hear. And this is our multiplication. Eh?
Mm-hmm. 18x over 12.
18x over 12 is correct. Can this be reduced or simplified?
Yeah.
So what I'll get?
Yes.
Over
Mm. Oh, my brain shut down.
That's alright, I understand. My brain shut down too. But so you see here what went on, but it have another way. It had a different way. Where's the different way? 2x over 3 multiplied by 9x over 4. Where's the different way? Scroll shot. So she multiplied numerators and denominators there to get the answer. But if we want, we could start cancelling off. This 2 will cancel off with this 4, and I'll have 2 over here. This 3 will cancel with this 9, so I'll have 3 over here. And now we multiply to get 3x on 2. You see that, Caitlin?
Yeah.
What if we had waiting
3x over 2x.
3x over 2x. How you get that?
We cancel 5 and 15, and then
5 into 5, 1. 5 into 15 is 3, right?
And then the 6 into 12.
6 into 6, 1. 6 into 12 is what? 2?
Yeah.
But x will cancel with x. And it's the same number. And x is the same number, so they will cancel off as well. So I will end up with 3 over 2. You understand that, Scotia?
Yeah.
Nice. I am waiting.
over 3x.
18y over 3x?
Yeah.
How is it that? Explain.
I cancel the 7 with the 14.
So 7 into 14, so I'll have 2 here, yeah.
I'll cancel the x next to the 14 with
this-
one of the x's.
X will go on here, 1. And this will cancel with x squared to just give you x. Yeah? And then,
so 3 multiplied by,
well, this 3 could go into this 9. 3, yeah?
yeah,
So that means that I'll have 2 times 3y, which is 6y, huh? All over x times 1, which is x. Caitlin, how you feel about that one?
Okay.
You understand that?
Yeah.
Do you understand how this x cancel with this x squared?
Yeah.
And I have an x remaining?
Mm-hmm.
Alright. Pretty good. Let's try this one. This is not a multiplication this time. This is an addition. But remember that you do it like any normal fraction. So what do I do first?
find the okay.
That is not the way that I had tell earlier to do fractions. Remember I tell earlier, forget about all of the LCM thing.
Yeah.
Why? What I tell earlier to do.
Multiply the two denominators.
Multiply the two denominators. And you'll see why I tell you to do that just now. Just now you will see why I tell you to do that, right? Forget about LCM and things. Forget about all of them things. Right? You'll always end up with the same answers at the end. So 5 4s are 20, but I'm not going to write 20. I'm just going to write 4 times 5. Right? 5 4s are 20. You'll see why after. So I'm multiplying my denominators to get the common denominator. What do I do now? How I tell a little to add fractions?
Multiply the 4 by the 2.
So you cross multiply now. So the 4 times 2x. 4 2s are 8x. And then you cross multiply 3x times 5. 5 3s are 15x. And of course this is an add there in the middle. So 15 and 8 is 23. Am I correct? Or 22? 23. 23x divided by 20. You can have your 20 then. How you feel about that, Scotia?
Good.
Do you see that it is no different from adding normal fractions?
Yeah.
Right. What about this? Sorry. What do I do here? Scotia.
Multiply the denominators.
Right. 4 3s are 12, but I'll just put 3 times 4 for now. And then what?
Multiply 3 by 3x.
which will give me what?
9x.
And then
2x by 4.
which is
8x.
minus there, right?
Yeah.
And I'll end up with 8 minus 9 is negative 1x over 4 3s are 12, which can also be written as negative x on 12. Caitlin, how you feeling about this?
Good.
Pretty okay, right?
Yeah.
Were you all always this good at adding algebraic fractions? Right? So what I'm trying to show you guys, it is exactly the same as if you're dealing with normal numbers. So what about this one? What do I do?
Wait, like normal?
Yep. So what do you do?
Multiply 3 by
So now you see why I didn't multiply out the 3 and the 4 to give you 12. I just leave it as 3 times 4. Because in this case, I could just leave that as 3 into x plus 2, and I could just leave it like that. Because if I expand it and get 3x plus 3 2s are 6, I could do that too, I could do that too, but sometimes leaving it like this is actually the simpler thing to do. Right? So what do I do next?
Multiply 3 by 2x.
Which will give me
9x.
9x, and then
Multiply 2x by the x plus 2 in bracket.
so I'll get 2x multiplied by x plus 2 plus 9x. Yeah?
Yeah.
And we can simplify this. So this can be simplified. You multiply out these brackets here, and then you add and you ting ting ting. You all want to simplify it, or you're good?
Simplify it.
All right. So this here is what we're actually gonna do now, which is something called the distributive law. And I think both of you guys would have been familiar with the distributive law already, where you take this number outside the bracket and you multiply it by everything inside the bracket. So 2x multiplied by x is 2x squared, and then 2x multiplied by 2 is 4x, and then I have plus 9x, and all that is over 3 into x plus 2. Now I could see 2x squared into 4 plus 9, 9, 10, 11, 12, 13. So that's going to be plus 13x divided by x, sorry, not x, divided by 3 into x plus 2, and that is as simple as I could get it. I don't think that anything could really do anything here. So Caitlin, you understand what we're doing here?
Surprisingly, yeah.
Yeah. So you can see the whole thing is just treating it like any normal numbers. That is the whole thing about this algebra business. There is nothing different about it. Nothing different about it. Right? So let me just do one last one before all you go. What about 2 2x all over 5 divided by 12x all over 25.
You put the 12x over 25.
So you invert and multiply. So 2x over 5 multiplied by 25 over 12x. Finish me off here.
5 times 25, that time.
5, there's 1, that's 5, yeah.
And the 2 to go into, well, 2x to go into 12x.
Well, the x's will cancel, and 2 into 2, 1, 2 into 12, 6. So this is 1 over 1 multiplied by 5 over 6. So the answer is 5 over 6. Caitlin, you alright?
Yeah.
Right, nice. So, we saw here, do you guys see what I'm talking about though? That, you know, you're dealing with all of this algebra stuff in the exact same way that you would deal with normal numbers.
Yeah.
You all seeing it?
Mm-hmm.
Yeah.
Yeah.
Right. So, let's just talk about this other thing that you all should know about. And it's called the Distributive Law. Right? So we know that if I have 3 into 4 plus 2, yeah, I could do the brackets first. 4 and 2 is 6, and then 6 3s are 18. Right? But the distributive law says that this 3 is being multiplied by everything inside the brackets, right? So therefore, I will have 3 multiplied by 4, and then I will also have the 3 multiplied by plus 2. So because it's a plus 2, I will end up with a plus over here, 3 times 2. So do you all understand the distributive law, Caitlin?
Yeah.
Alright, let's see how well you understand it for real. What if I had 2 into x plus 2? What am I going to get here?
Yeah, it's still 4.
2x plus 4. You understand why, Caitlin?
Yeah.
Alright, good. What if I had 2 into x, alright, not 2, forget 2. What if I had a into x plus y? What am I going to get here?
Ax plus y.
Right. Caitlin, you alright with that?
Yeah.
A multiplied by x, and then a multiplied by plus y. And Caitlin?
Yeah.
Right. So Caitlin, what am I going to get with this one?
Ax minus a.
Very good. A x, positive a times positive x is positive ax. Positive a times negative y gives me negative ay. Nice. What am I going to get when I multiply this?
minus ax minus ay.
Negative ax minus ay. Caitlin, you agree with this?
This one is right.
Huh?
I guess so.
Right. Don't be afraid if you agree with it. Do you agree? Does it make sense to you?
Yeah.
Right. Well, it's correct. It's correct. I just like creating doubt in all your mind, you know? But yeah, you have a positive a times a negative x. So that'll give me a negative ax because the signs are different, will always be negative. And then I have a positive a times a negative y. So that will give me minus ay for the same reason. What if I had negative a times minus x minus y? What am I going to get here?
Ax plus ay.
Caitlin, what do you think?
Ax plus y.
Very good. Ax, because negative a times negative x is positive ax, and a negative a times negative y is positive ay. Nice. And this is the distributive law, right? But we have one other step again with the distributive law. That sometimes you will see two sets of brackets like this. A plus b multiply by x plus y. What does this give me? What does this mean? That this a plus b is being multiplied by everything in the brackets, eh?
Yeah.
So you could think about it like the a plus b is being multiplied by the x, and then the a plus b is being multiplied by the y. Caitlin, you okay with that?
Yeah.
So now I'll end up with ax plus bx plus ay plus by. Everybody cool?
Yeah.
Right. Caitlin, you alright, huh?
Yeah.
So you could see here that the a is being multiplied by both the x and the y. And you could see here that the b is being multiplied by both the x and the y. And are you okay with this?
Yeah.
Right?
Yeah.
Right? So if I want, I could rearrange it. Put the a's together. A plus ay plus bx plus by. So the a's are being multiplied by the x and the y, and then the b's are being multiplied by the x and the y. And
Yeah.
right, so look at this. Look at the difference between this and this. And I want you to recognize that they are the same. Yeah, they are the same. So essentially, what you could do when you are met with a situation, you guys write this down, right? I hope I'll write it.
Yeah.
Yeah.
So when you are met with a situation A plus B into X plus Y, what you could simply do is take the A and multiply it by the X and then multiply it by the Y. And then you take the B, multiply that by the X and multiply it by the Y. So what we will end up getting, if you take A times X, that will be AX. And let me write it in red because I'm dealing with A. AX, and then A times X is AX, A times Y is AY, and then B times X is BX, and B times Y is BY. Understand this, Caitlin?
Yep.
Alright. If all you understand it, then tell me what this is going to be. What's that gonna be? Come quick, somebody.
AX plus AY plus, minus BX minus BY.
Caitlin, how do you feel about that?
Good.
Good? Alright. What about this one? Let me see how good Caitlin is. Come, Caitlin, let me see you. Show me your skills.
AX plus AY plus plus BX plus BY.
Very good. You agree with this, Kosha?
Yeah.
Alright, nice. So, we have the distributive law here. We have two different kind of versions of the distributive law, where we have two brackets and where we just have one bracket. Nice. Any questions so far on any of this? You guys understanding all of this stuff so far?
Yeah.
Right? Is algebra easier for you now? Does this answer a lot of your algebra questions that you've had in the past? Does this help in any way at all? I hope it does. Right? No. Number one. X plus 2 equals 6. Solve for x. What x is going to be? Quick.
4.
How?
Yeah, transpose the 2.
So x is going to be 6 minus 2. And
Yeah.
for the same reason we was talking about, you minus 2 on both sides of the equation. And? Yeah?
Yeah.
So x is equal to 4. You okay with that, Caitlin?
Yeah.
Alright. Two x is equal to 6. Solve for x.
if you transpose the 2, but since it's multiplication, it's going to division.
You could transpose the 2, but since it's a multiplication, when you fling the 2 over, it's going to turn into a division. Why does it magically turn into a division? Is it a werewolf? Does it only happen on full moon? Like,
No.
well, then why does it magically turn into a division? Is that magic? Caitlin, can you explain?
Because it went over the equal sign.
Yeah, so when you jump over the equal sign, you just turn different. Right? What are you actually doing to get rid of the 2 from this side of the equation? It's a yes, it's a multiply by 2 here. So in order to get rid of it, you have to divide by 2 on both sides of the equation. Divide by 2 on both sides. So now I'll have 2x divided by 2, which is equal to 6 divided by 2. Right? So these 2's will cancel. So now I'll have x is equal to 6 divided by 2. X is equal to 3. Now, it's easy for us to fling the 2 across and jump from this step to this step. But this step here is y. You understand?
Yeah.
This step is why that works. And that is the more important thing. Knowing why it works. You okay, Caitlin?
Yeah.
Well, let me see how okay Caitlin is, right? 3x on 2 is equal to 9. What am I going to do here?
Transpose the 2.
Transpose the 2 and that'll give me what? Alright, it'll give me 9 multiplied by 2, and
Yeah.
so 3x is equal to 18. And then what?
Divide by 2.
Divide by 3. So x is equal to 18 divided by 3, and
Yeah.
which is 6. Alright? So the whole point of this is, you know, when you're transposing, if you're transposing something that's an addition, it will become a subtraction. If you are transposing something that is a multiplication, it will become a division. And if you are transposing something that is a division, it will become a multiplication. Everybody understand these concepts?
Yeah.
Right. So you could see here that the process of transposing involves moving things across the equal sign so that I will end up with x alone as the subject of the formula. And you agree with this, Caitlin?
Yeah.
So this brings us to our next topic, subject of the formula. Because guess what? You guys have been doing algebra for a very long time, right? Name some formulas that you guys know, just off the top of your head, real fast. Well, there are no formulas at all.
Okay, well, well.
Just give me some formulas, the man. Anything. Simplest formulas ever. Caitlin. A simple formula. Let me hear it.
A times B is AB.
There's a formula for what? That is not a formula. Give me a formula you actually know from maths.
A squared plus B squared equals C squared.
You, that's an ugly one. That's an ugly one. Any other formulas? Give me some formulas. Things you know from SCA. Pretend this is the first time you're doing algebra. So you are gonna know about Pythagoras theorem yet. Right? What's some formulas you know from SCA? What about area is equal to side by side? And that's a formula?
Yeah.
Right. What's another formula? Area is equal to length times breadth, eh?
Okay.
Give me some others. Well, what is some others? Area is what? Base times height over 2, eh? You all know this one?
Yeah.
That's the area of what?
That was only triangle.
That's the area of a triangle. And why is that the area of a triangle? Base times height over 2. It actually came from the area of a rectangle. A rectangle or a square, it does not matter whether it's a rectangle or a square, but you have the height, you have the base. So the area of the rectangle is simply base times height, and then when you cut that in 2, like that, you get a triangle. So you divide that in half. You understand? Did you know that, right? You all knew that, right?
Yeah.
Right, I hope so. What about area is pi r squared? What about circumference is 2 pi r? What about volume is pi r squared h? So you guys remember these formulas?
Yeah.
Right. So let's take a simple formula by chance, right? Let me just take area is equal to length multiplied by breadth. Or let me not use length and breadth. Let me use breadth and height. Right? What if you have the area, you have the breadth, but you want the height? So you have to make the height the subject of the formula. What you gonna do? What you gonna do? Alright, but the first thing I will do is this, right? Because I want the height to be on this side of the equal sign, I'll rewrite the equation BH is equal to A. So now I have the height on this side of the equal sign. And all I doing is transposing the B. So H is equal to A divided by B. Yeah? And my H is the subject of the formula. You understand that, Scotia?
Yeah.
Right? So what if I have area, alright, no, not area. Volume is equal to pi r squared h. And I tell you, make R the subject of the formula? These are tough ones. Let me see how good are they. What's the first thing we should do?
Rewrite this.
Rewrite it. So we'll flip the equation so R will be on this side, right? So pi R squared H is equal to V. What next?
Transpose everything else.
Alright, I like that too. So what is everything else?
Pi, one of the R's and
Pi, one of the R's and the H. My problem is, how am I going to throw one of the R's over here if it is that I want R to be the subject of the formula? Yeah?
yeah.
So, I like where it was going though. We don't have to tackle the R yet. We could throw across the pi and the H, eh? Because this is really R squared multiplied by pi H. And Caitlin?
Yeah.
You following, right?
Yeah.
So now I could throw across the V divided by pi H. So I have R squared is equal to V divided by pi H. But the problem is, I don't want R squared, I want R. So what to do from now? And we talked about this in the last couple of classes when we were talking about squares and square roots. And remember, you just treat it like any other number. Don't let V and pi and all of them things get you frightened. You treat it like any other number, huh?
Divide R on both sides.
Yeah, but if I divide R on both sides, I'm gonna end up with R on this side, eh? Yeah, I'm gonna end up with divided by R here, and I'm gonna end up with divided by R here. So yes, I'll end up with one R on this side, but what to do with the R on this side, you know? So, I don't know. What do you do when you have a square? What do you do when you have a square?
Square it?
Yes, because if 5 squared is equal to 25, then 5 is equal to the square root of 25, and yeah, that is it. Think about it like any other number. So this here is your little example. So therefore, if R squared is equal to all of this blah blah blah, then R is just going to be equal to the square root of all of that blah blah blah. And Caitlin, you understand that?
Yeah.
I tell you, this one was a little bit tougher. This one was a little bit tougher, but that's as tough as it will get to be. So today, we dealt with a lot of stuff. We talked about what is algebra, and we saw that algebra is a language of mathematics using unknowns, variables, and generalizations. We started to talk about simple addition and subtraction, and we also spoke about this whole transposing thing, and you saw that transposing was a normal basic arithmetic. We were always doing transposing. We were doing it since basic arithmetic, right? We came up with some of the generalizations for addition being commutative, for multiplication being commutative. we spoke about the multiplication and we reminded ourselves of these rules that you must always remember, especially with addition. And we saw that algebra does just work like any normal numbers. So you have to know your arithmetic. Your problem is not algebra, your problem is arithmetic. For example, how long did it take for you guys to give me this? How long did it take for you to tell me that a half x is the same as x on 2? Because I'm telling you, this is where it does make your problem in algebra. It is this here that does give you guys the biggest problems in algebra. Not thinking about it like normal numbers. You all just think that x is something special, but no, x is just a normal number. We saw it here when we were doing fractions. You do it exactly the same way. No matter how complex or complicated it end up looking. It might look complicated, but it really just no difference from any normal number. And we saw that since we could take these unknown generalizations and we could just treat them like normal numbers using transpositions, then we can actually change the subject of many of the formulas that we already knew. So are you guys okay with all of this? Any questions?
No, I don't have any questions.
Caitlin, you alright? Alright, let me see how alright you all really are. Alright. Number 2. How are we doing this? Quick, what's the first thing to do? Quick.
Multiply the denominator.
Right, forget about LCM and thing. Just multiply the denominators, 3 and 9, and then what?
Multiply 3 by the x minus 2.
So that is 3, and it'll be on this side into x minus 2, and then what?
Multiply the 8 x by 9.
Alright, 9 eighths are what? 56? 9 eighths are 72.
Yeah.
72x, and then I'm adding it, right?
Mm-hmm.
Right, so that will give me what? 72x plus 3x minus 6, all divided by 9 3s are 27. Yeah?
Yeah.
And now I can go 72 plus 3 is what?
75.
Minus 6 divided by 27. Can this simplify any further?
No.
Caitlin, you okay with this?
Yeah.
Alright. Caitlin, you do this one. Yeah, you give me this one here. 2x. 2 into 2 plus x is equal to 10. Solve for x. Quick.
2 into 2 plus 2x equals 10. And then you transpose the 4.
That's correct.
Yeah. And then L equal to 6 is then transpose the 2.
That's 2.
2
Alright, I was just checking. And then x is equal to 4. No, 3, sorry. Alright, 3 2 6. Alright, good guys. So that is it for today's session. Was it a long, drawn out session? Did it?
Kinda.
It was kinda long. It felt long.
A little bit.
Wow. Did it feel long to you, Caitlin? Alright, we'll see. Well, let me just show you something here before I let you go.
The assignment?
Yes. And I'm sure you guys have seen the assignment pop up in your email. So when you go to CSEC classwork, are they seeing this, right?
Yeah.
Right. So we have the welcome. I decided to go from the top down. So I put the number theory on top. And these are all of the classes. We did 6 classes in the number theory. So you can always come and check them out. When you click on a class, you just actually get the description of what it is we looked at in that class. So in this class, we looked at BODMAS with fractions. If we look at this class here, 5 and 6, we'll see that class 5 was an exam. Here is class 6, the corrections for the exam. Wait now, where is the, it do have the, look, it do have the video, yes? So I had to post the video for that. I had posted it, you know, I just didn't put it here. But I do have it on YouTube, so I'll go and I'll post that now, yes? The corrections for the exam. So that is good. So this here, right after number theory, we have the introduction to algebra. And this introduction to algebra here, oops, sorry. This introduction to algebra here is what the assignment you guys are going to be doing. And when you click it here, you'll see that we have this page and we have answers. We have these here and we have answers. And then we just have some subject of the formula questions. So I need you guys to do this. This is due for Saturday at midnight. Alright. And so do that. Number theory. After number theory, we have the introduction to algebra. So just do that and hand me your assignments by Saturday. We're gonna be correcting all of that on Saturday just to see how to do all of it, right?
Okay.
And please show all of your working. That is it for today. I'll see you guys Saturday.
Bye, sir.
Bye bye.
Bye.